are moving on to lesson 1.7 on circles. So let's go ahead and maximize this screen a bit. Maybe not. There we go. All right, so we are going to define a circle and related figures to the circle. Again, continuing with our practice of creating definition, we're going to identify parts of circle, review how to construct circles, and some more skills we're going to use. That's more in our exercises in class. And then develop writing skills and cooperative behavior. So some constant definitions that we are used to seeing. All right, let's take a look at our first circle. So the definition of a circle is the set of all points in a plane at a given distance from a given point. All right, so we call that given distance a radius. So from the center out to the point, that's the radius. So that's our given distance. And then the center is the given point. So that is the exact center, and then every point going around the circle, all right, that's what makes up the circle, or all those points. When we identify circles, we name it by its center. So this would be circle R, or sorry, that's not an R, circle Q. So pretty simple. Go ahead and copy that down into your notes. Again, at any point, pause as you see necessary to continue if I'm moving too quickly for you. All right, this time you're going to write your own definition. I defined for you what a circle was, but now for the parts of the circle, I would like for you to define it. So, first word we have is chord. All right, very similar to the spelling of a chord for guitar playing. All right, so looking at the pictures, here are chords on the left-hand side, all right? And over here on the right-hand side are some pictures that show us things that are similar to chords, but aren't. So what do you notice about chords on the left-hand side that aren't happening on the right-hand side? Notice also down here, underneath it's got a picture that has named for you the chords shown. And up here, on the right-hand side, it's naming for you the things that are not the chords. All right, when you've written your definition, move on to the next one. Diameter. All right, I think we all have a pretty good understanding of what a diameter is, but let's just double check. So on the left-hand side, we've given you 3 diameters. And then on the right-hand side in our circle, we have some other points and other segments and things like that, but they are not diameters. What is important to make something a diameter versus it not being a diameter? All right, when you've written your definition, you're ready to move on, go ahead and move to the next slide. All right, our last vocabulary term is going to be tangent. So on the left-hand side, we have a picture of some things that are tangents, and then on the right-hand side, some things that are not tangents. So what do you notice happening with the tangents that is not happening on the right-hand side? So what do you think a tangent is? And maybe the next vocabulary term will help clarify some things for you. When it says that the point of tangency is the point on the circle where the tangent touches it. All right, so the point of tangency. So for example, on the left-hand side, on the things that are tangents, the point of tangency for one of those, let's say tangent CD, the point of tangency, I'm going to call it POT here, all right, is point C. All right, that's the point of tangency. So let that help guide you in your definition for what a tangent is. All right, some other vocabulary terms. Oops, I did not hit the right button. Let's try that again. There we go. Some other vocabulary terms, we have congruent circles. So you actually do need to write some more definitions down. I've only given you the picture of what it is, congruent circles. Notice what makes something congruent. All right, so look at those 5 circles. What do you notice about them? And then concentric, all right, concentric circles. So looking at this dartboard, we have a circle going around the outside of all the numbers, and then we have the circles on the inside that are the alternating red and green circles. All right? What do you see? What do you notice about the circles? And what do they all have in common? All right, so just write your definition, and when you're ready, go ahead and move on. Talking about arcs. All right, another thing we're going to discuss in circles will be arcs. This is just an intro. Later in the semester, we will get into more detail when it comes to circle properties and things like that. But good words to know. An arc are 2 points on the circle and a continuous unbroken part of the circle between the points. The points are the end points of the arc. So let's go ahead and put some points on our circle here. Let's say, oops, I did not go through the center like I wanted to. Let's try that again. No, still not going through the circle, so I'm going to make my center a little bit bigger. My calibration appears to be off a little bit. And let's call this point A, and we'll call this point C. And I'm going to put another point up here on the circle that I'm going to call point B. All right, so a semicircle are the endpoints of the arc are the endpoints of the diameter. So notice that AC is our diameter. So to call it a semicircle, we actually wouldn't say semicircle AC. When we name a semicircle, we have to name it by 3 points. And so we would call this, the arc, we would call it arc ABC or arc CBA, whatever you want to call it, but A and C being the endpoints. And we use this little symbol, looks like a little umbrella, over the points to call it that arc. So this is semicircle ABC. So top half is half the circle, the bottom half is half the circle. That's going to be our arc. A minor arc, let's say I have something less than a semicircle. I'm going to get a different color for us. We'll go with dark green. And I want to identify an arc. Okay, so the semicircle cuts the circle in half. So let's say I choose a section of the circle that's less than a semicircle. If I choose a section of a circle that's less than a semicircle, we call that a minor arc. And I can call a minor arc, when I name it, I only need 2 points, just the endpoints of the arc. Now if I want to call a section that's greater than a semicircle, and I want to identify that, let's say I'm going the other direction. So a section of the circle that's greater, there we go, try and get that whole circle there, that's greater than a semicircle, we call that a major arc. Now, when we identify major arcs, we definitely want to make sure we call it by its 3 points. So the end points, and then some point that's in the middle. So in this picture, that would be point A that's in the middle. If I called it BC, if I said that this was arc BC, I wouldn't know if I meant the major arc or if I meant the minor arc. So for semicircles and for major arcs, you have to use 3 points to call it. And for minor arcs, you can use 2 points. All right, so copy down what you need, and when you're ready, move on. All right, so taking a look a little bit more in detail of our circles. Again, an arc, 2 points on the circle and the continuous part of the circle between the points. The points are the endpoints of the arc. We've already talked about that. Now the arc measure, so if I have a whole circle, a full circle, that's 360 degrees. I think most of us know that. The arc measure is going to be the same as the central angle. So let's take a look at this picture going on right here. And I'm going to go ahead and go back to my blue pen. And notice that I have this arc right here, BC. Okay? Now, that section of the circle, all right, the angle, the arc measure, is going to be the same corresponding. So I have my center here. I draw a segment, the radius, going from the center to point B and the center to point C. Whatever that angle is there in the center is going to be the measure of the arc. So whatever that's the same angle. And then if we want to know, that's for the minor arc. If we want to know the major arc, so everything else going from point B to point C going in the opposite direction, that's the reflex angle. All right, so that's going to be basically the opposite. 360 minus 45 degrees gives us 315 degrees. So the major arc has the angle measurement of 315 in this example, while the minor arc has the measurement of 45 degrees. So we'll have some experience measuring some arcs to get us a better understanding. But for now, that is it when it comes to introducing circles. As I said before, we will talk more of these in later chapters.